Last week, we looked at how to calculate the value of a function given a value of x. So like, for example, if f of x is x squared minus 3x plus 2, find f of 4. It just means that we want to know what would be the corresponding y for f of x value when x is 4. So you substitute 4 into the expression for the function, replacing x with 4. So it's substitution, right? So we did that last week. And we also looked at how you can find the value of x if you know what the function is equal to. So like if f of x is given or is defined as 2x plus 1 and f of x is 7, what is the corresponding x value? And to do that, you would have to put the expression, equates it to the value of f of x. So in this case, if the function is defined as 2x plus 1, you make that equal to 7, and then you solve for x, right? So 7 is equal to 2x plus 1, then 6 is equal to 2x, so x is 3. Today, we're going to spend some time learning about the domain and its restrictions. So the domain of a function and its restrictions. Now, to get started, we need to recall what is the domain of a function. And the domain of a function is all the set of all possible input values. That's your x values, right? So which x values you can substitute into that function and get a corresponding y value. That's basically what the domain is. And then your range is the set of all possible y values, right? Now, it's not always the case that your domain will be all the real numbers. Typically, the domain of any function is all the real numbers, but sometimes you may have a restriction on the domain. And all that means is that the function cannot exist at that point, right? So when you have to divide by 0, for example, if a function is, if it's a rational function, then and the denominator is equal to 0, then you cannot, the function is undefined at that point, right? So let's look at an example to make that make more sense. Well, if let's say a function is f of x is equal to 1 over x minus 2. Now, if I substitute the value, let's say I substitute the value 3 into this function. So if I wanted to find what is f of 3, I could do that because it'll be 1 over 3 minus 2, which is 1 over 1, which is 1, right? So it does yield a value for that. If I could even do f of 5, right? So f of 5 here will be 1 over 5 minus 2, which will be 1 over 3. So I have the function does exist when x is 5, and just now it existed when x was 3. But when x is 2, this function will be undefined because when f is 2, that means we're finding f of 2, right? When x is equal to 2, it'll be 1 over 2 minus 2, which will be 1 over 0. And this cannot be worked out. You cannot divide by 0. And so this function is undefined when x is equal to 2. So for whatever value that makes the denominator, in this case x minus 2, whatever value of x that makes this equal to 0 will be where the function is restricted or where it is undefined, all right? So the domain of this function, 1 over x minus 2, will be all the real numbers, right? It'll be all the real numbers except when x is equal to 2. Because when x is equal to 2, the denominator of this function will be equal to 0. And you cannot have 0 in the denominator. All right. So another example could be like if you had 1 over x. If the function f of x is 1 over x. Well, the restriction here will be x cannot be equal to 0. X could be any value but 0 because you cannot have 0 in the denominator, right? If I had, let's think of another example. Let's say the function is f of x is equal to 1 over 2x plus 1, right? So my domain, let's see what values would make this equal to 0. So to find out what values will make this denominator equal to 0, I could simply take it out and write 2x plus 1 is equal to 0, and then solve for x here. So this will be 2x is equal to 0 minus 1, and so x is equal to minus a half. So it means that this function, the values, the domain will be all values of x, all the real numbers, except when x is equal to minus a half. Because when x is equal to minus a half, the denominator here will be equal to 0. So that's one restriction on the domain when you're looking at rational functions. And when I say rational functions, I mean functions that are in the form of a fraction. So like if you have 1 over x minus 2 or x over 3x plus 4, any function in the form px over, let's say, qx, this is a rational function because it's a fraction, right? So any of them, it means that the denominator cannot be equal to 0. So any value of x that can be substituted and will make that denominator equal to 0 will be a restriction on the domain. The function is undefined at that point. So the next time when you would have a restriction on the domain is if you need to find the square root of a negative number, right? So the first one is your division by 0. So a function is undefined if the denominator is equal to 0. And then if you have to take the square root of a negative number, the function is also undefined where that value will make you have to take the square root of a negative number. Here's what I mean. If you have a function f of x is the square root of x minus 3, remember square roots only exist you could only find the square root of a positive number. The answer itself could be both positive or negative, right? So like, for example, the square root of 4 is equal to positive 2 or negative 2. But you cannot find the square root of negative 4, sorry. You cannot find the square root of negative 4 because no two numbers, when multiplied by itself, can give you a negative number. Unless, yeah, correct. No two negative numbers or two positive numbers can multiply by itself to give you a negative, right? The only time you can get a negative number is if you multiply a positive times a negative, and that would defeat the whole purpose of squaring, right? Because squaring is multiplying the same number with the same sign by itself. So like negative 2 times negative 2 is 4. That's why the square root of 4 is negative 2. Or positive 2 times positive 2 is also 4, which is why the square root of 4 is positive 2. However, you cannot find a number. So negative 2 times negative 2 wouldn't give you negative 4. It'll give you positive 4. So the square root of a negative number does not exist. And so if you have a function, right, like this one, the root of x minus 3, inside there must be greater than or equal to 0. The square root of 0 is 0, by the way. So the domain here will be any value that makes this inside of here positive. So if I wanted to say f of 12, right? I could find f of 12 because that would be the square root of 12 minus 3, which is the square root of 9, which is 3, right? Plus or minus 3. So that works. It doesn't even have to be a square number. I could use any number in there. So like if I wanted to find f of 5, for instance, that can also work because that would be the square root of 5, take away 3, which is the root of 2, right? But if, for instance, I wanted to find f of 2, what would happen here is that would, wherever I have x, I would replace it with 2, and that would make this equal to 2 minus 3, which is -1. And I cannot find the square root of -1. So the function does not exist when x is equal to 2. All right? In order for the function to exist, has to be greater than or equal to whatever is inside here must be greater than or equal to 0. So what you would do is you would substitute, you would put x, you would take what's inside the square root, which is x minus 3, and you'll make that greater than or equal to 0 and solve this inequality to see what value will be greater than or equal to 0. And so it will be x is greater than or equal to 3, right? So x can take, for this function, f of x is equal to root of x minus 3. This function can be, the domain could be any value of x that is 3 or greater than 3. Right? So it could be 3 because if it's 3, then it would make inside of the function there, instead of the square root, that'll be 3 take away 3, which is the root of 0, which is 0, right? Or it could be even 4. 4 take away 3 is 1. So that'll be the square root of 1, which is 1. And it goes on and on and on. But any value that's less than 3 cannot work. The function will be undefined because any value that's less than 3 in here will make this function undefined, since it will make the square root be negative, -1, -2, etc. You cannot take the square root of a negative number. So that's what you have to know, right? You need to understand that the domain of a function can have some restrictions, and those restrictions will be basically just these two for this level, right? If you have to take the square root of a negative number, or if you have a rational function where the denominator is equal to 0. Okay? So those are the two times, guys. So just a quick summary. Things that we already looked at. We looked at what is a relation, what is a function. We looked at the vertical line test. We looked at function notation. And now we just looked at the domain. Right? So I want to continue a little bit on the domain and the range, because I think that many times students don't quite understand what the domain and the range is. So let's look. The domain, guys, has to do with all your x values. And if you think of the Cartesian plane, your x values are your horizontal axis, your values that correspond with your horizontal axis. And then your y values are your vertical axis, right? So when you're looking at the graph of a function, you can determine what its domain is and what its range is. So on this function, as you can see, the domain is from -3 to 1. So that will be your domain, right? But something else that we're looking at, now this is drawing on your memory of inequalities. When you have an unshaded circle, it means that the value is, it's an exclusive inequality. So just to refresh your memory a little bit on inequalities, right? When you have a shaded circle and the arrow is going in a direction, in the right direction, this means greater than or equal to. If you have an unshaded circle and the arrow is pointing to the right, this means greater than. When you have a shaded circle and the arrow is pointing to the left, this means less than or equal to. And when you have an unshaded circle with the arrow pointing to the left, this means just less than. So unshaded means exclusive inequalities, which means that that value is not included in the solution set. So for example, if I had the number line, right? So let's say this is the number line, 0, -1, -2, 1, 2, 3, right? And I have a shaded circle above 1 with my arrow pointing to the right. Well, this would mean x is greater than or equal to 1. But if I had an unshaded circle, right, with the arrow pointing to the right, this would simply mean x is greater than 1. So 1 is not included in the solution set here. Likewise, let's say I had a shaded circle and my arrow is pointing to the left, this would mean x is less than or equal to 1. But if I had an unshaded circle with my arrow pointing to the left, this would mean x is less than 0, right? So this is just, we've done this before, but I just saying that just to refresh your memory a little bit, because in this graph here, we have the unshaded circle and then we have a shaded circle. So if I had to identify the domain, you are looking at the x values of the graph, right? Where the graph is drawn. So the x values here, well, here, this would be x is greater than -3, because you see all the values of x is to the right of -3, which means they're all greater than -3. And since it's an unshaded circle, it's an exclusive inequality, so -3 is not included in that solution, right? However, on the right-hand side here, you have all of the values to the left of +1, and you have a shaded circle. So how I would describe this point, I would say x is less than or equal to 1, because all of the values of x lie to the left of 1 with a shaded circle. They're telling us that 1 is included in this function. So the domain then, if I were to write the domain of this function, I would say that x is greater than -3 and less than or equal to 1. So I could write it like that. I could combine it and write it like that. Okay? And then if I look at the range is all your y values, right? So the highest value of y here is 0, right? Remember, your y values are your vertical axis. So the highest value of y here is 0, and the lowest value of y is -4, meaning that there's no point below -4, right? No point has a y value less than -4. Now, on the same hand, no point has a y value greater than 0. So your range of this function, your range is y is less than or equal to 0 and greater than or, less than or equal to 0 and then greater than or equal to -4. So that's how I would write the range. All right, guys. So your domain, when you're looking at a graph, your domain are your x values and your range are your y values. So let's look at this one, right? So the graph of a function, finding the domain and the range of a function. So here again, we have, they don't have numbers on this one. So we could fill it in. Well, here would be 0. Here would be 0. Here would be 1, 2. And then you have 1, 2, 3, 4, 5 on this side, right? So your x values, as you can see, remember when you're thinking about the domain, we are thinking about where the graph, what are the x values on this graph, right? So these are your x values on this graph here, from -2 to 5. Oh shucks, why didn't I put in the negative numbers? -1, -1 and -2, right? So your x values here would correspond to -1 and +5, all right? And that's why the domain of the function here is given as -2 to 5, right? So you could write it like this, or you could even write it as x is greater than or equal to -2, and of course here it's an exclusive inequality, right? Because the circle is unshaded. So it will be less than 5. And then to find the value of f of -2 and f of 2, guys, f of -2 means what is the value of the function when x is equal to -2. So you go on your graph and you check to see where is x equal to -2. This is where x is equal to -2 here. And then you read the y value. So the y value when x is equal to -2, you're reading from your x-axis. This is -2. So then you go up and then you come across. And what value does that correspond with? It corresponds with, this is 1, 2, 3, and 4. So if I were to write this, I'll say f of -2 is equal to 4. And similarly, if I were to find what f of 2 is, what f of +2 is, I find x is equal to 2 on the graph, and then I read where the graph, what is the coordinates of the point where x is equal to -2, which would be here. And that is, here is -1, -2, -3, and -4. So therefore, f of 2 is -4. So you can read off values from the graph itself, right? You don't need to know what the function itself is, like what it is defined as. You can just look at the graph of a function and you can figure it out. And then finally, if I'm looking at the range, well, remember the domain has to do with your x values, right? Your range has to do with your y values, which is your vertical axis. So here, the highest value of y on this graph is here, this value here, which corresponds with 1, 2, 3, 4. And then the lowest value of y on the graph is here, which corresponds with -1, -2, -3, -4. So therefore, your range is -4 to 4. So I can write it like this. The straight bracket means it's an inclusive inequality, right? So that's why on this side, when we were representing the domain, we had a straight bracket here, right? The square bracket for the part that it's -2, since x is greater than or equal to -2, and we had a curved bracket for when x is less than 5. But here, x is equal, greater, less than or equal to 4 and greater than or equal to -4. So if I were to write it, not x, sorry, if I were to write the range, I would say y is greater than or equal to 4 and less than or equal to -4. All right, let me ask you all a question based on this. So we already identified the range, and I just showed you how would you figure out a value of like what is f of -2. Can anybody tell me what f of -1 will be? F of -1, or would f of -1 be? Let's see. Genesis, what do you think f of negative from the graph? What would f of -1 be equal to?
Um,
Do you know what I mean by
-1.
what would f of -1 be equal to? F of -1. Do you know what I mean by that? Like what I mean by what is f of -1?
Was the next point on the graph?
It's the point on the graph where x is -1. So where is x equal to -1 on the graph? At
Right
what
there.
value of
Well,
y? So your y values here, this will be 1, 2, 3, 4. This is -1, -2, -3, -4. These are your x values on your horizontal axis, and these are your y values. So what is the value of y when x is equal to -1?
x is -1 as well.
Because that would be here. Is this point on the graph? This is the
Oh,
point negative
no.
1, negative 1. So that's not a point on the graph, right? So try again. Where would it be? It has to be a point on the
0.
graph. If it's 0, that means that's this point, because this point is negative 1, 0. Is that point on the graph?
I don't know.
So neither of those points lie on the graph. Try again, honey. Let me show you what f of negative 2 and f of 2 is again, and then you'll tell me, right?
Okay.
So f of negative 2, this is where, let me show you. This is where negative 2 is, right? So f of negative 2 would be from here, and the value of y that corresponds with when x is negative 2 is 4. So f of negative 2 is equal to 4, right? Because the point on the graph where x is negative 2 would be this point. All right? Because this point, the value of the coordinates of that point, sorry, is negative 2, 4. So that's why f of negative 2 is 4. Similarly, f of 2, well, x is equal to 2 over here. So I read from there down to the graph to see what's the y coordinate that corresponds with when x is 2. And as you can see, that the coordinates of that point is 2, negative 4. So therefore, f of 2 is equal to negative 4. So my question to you is, what will be f of negative 1? Are you seeing where x is equal to negative 1?
Next to negative 2.
Right. Well, yeah. Well, here is negative 1, right? So what was the coordinates of the point on the graph where x is equal to negative 1?
The, the second block on top.
Here?
I think, I don't know.
Yes, it is here. Because at this point, isn't this x equal negative 1 here? That's the coordinates of that point, right?
Yeah.
This point over here, this point here, x is negative 1, right? Because this is where x is negative 1. And then the value of y, what would be the y value here?
1.
1. It'll be 1, correct, right? Because this is here, this is 1, 2, 3, 4. So the point on the graph where x is negative 1 will be 1. So therefore, f of negative 1 is equal to 1, right? Let's see. Thank you, Genesis. Guys,
Yeah.
what about when x is 1? Where on the graph, what is the corresponding point? What's the corresponding coordinate? So what is f of 1? It is f of 1. F of 1. Ari, what's f of 1? Is Ari there? No, Ari is not here. Safi, are you there?
Yes, miss. And I was just about to ask you to re-explain it a little bit because I'm tired, so it's a bit hard to catch on to.
Okay, so the function, right? First of all, you all know how to read coordinates, right? You all have done this before. So I know you guys know how to read coordinates. So for example, if I put a point here, this point that is already on the graph, this point is the coordinates of this point will be negative 2, 4, right? Because the x coordinate is negative 2, and then your y value is 4, right? So that point is negative 2 and 4. Remember, with a function, your x value is your domain, right? And then your y value is really your f of x value, right? So if I have the point -2, 4, this means how I interpret this is that f of -2, the value of the function when x is -2 is equal to 4. That's how you interpret a coordinate on a graph, right? So similarly, this point, this other blue point here, the coordinates of this point is 2, -4, right? Because x is -2 here and y is -4. So that means I can write that as an ordered pair. Remember, we can write functions as ordered pairs. We could represent them on a graph or we could write them in a table, right? So here, your ordered pair for this point will be 2, -4. And I can write this in function notation as f of 2 is equal to -4. Genesis and I just went through what the value of f of x is when x is -1. So all I do to find out what f of -1 is I literally find the point on the graph where x is -1 and find the corresponding y value. So the coordinates of this point here when x is -1 will be -1, 1. So therefore, f of -1, sorry, is 1. All right?
Yeah.
Safi, does that make sense?
Yeah.
So this point here is when x is equal to 0 and y is -1. The coordinates of this point here is 0, -1. Therefore, f of 0 is equal to -1. So my question is, what is f of 1? On the graph, what is the corresponding y value when x is equal to 1?
Mm. Um, you put the dot under the positive one.
It will be there. It will be, let me show you. So on this graph, right? The points where you're correct, it's where it's below. Are you referring to here?
Yeah.
Are you referring to there?
Yes.
Yes. So what's the y value of that point?
It would be, oh dear. Um,
So here is 1. This is your
one.
x values, right? And now
Yeah.
you're looking at your y values. Your y values are on the vertical axis. So this corresponds to this value here. What value is this on the y-axis?
-3.
-3. So the coordinates of this point is what?
1, -3.
Excellent. So if I were to write it in function notation, it would be f of 1 is equal to -3.
Okay.
Guys, I'm spending this time with you all because I want you guys to start to make connections between what you're learning, right? You've learned before how to plot points on the Cartesian plane. It's not random, it's all connected. Everything on a Cartesian plane, any graph, is a function. It represents a function, right? Or it represents a function or relation. Sometimes it could be a one-to-one function. Sometimes it could just be a many-to-one function. This is a many-to-one function because it will fail the horizontal line test. Right? So I want y'all to learn things in that kind of in make connections between what you're learning. So for example, on this graph, there is no point that goes below -3. Do you realize that? On this graph, there is no point that goes below when y is equal to -3. That's the lowest value of y on this graph. And so the minimum value of y, or of the function f of x, is equal to negative 4. This is negative 4. So negative 4 is the minimum value of this function because there is no value lower than negative 4 on this graph. All right? And if you'll recall, we looked at minimum values and maximum values of quadratic functions. This is a quadratic function. As you can see, it's a curve. And any curve like this is called a parabola, and it represents the function or the graph of a quadratic curve, right? So you have a minimum value. It means that there is no value of y, right? There's no point on this graph where you have a value lower than negative 4. It's the lowest value, the lowest y value here is negative 4. All right, so let's take a short break, girls. Let's take a short break and then we're gonna come through. We're gonna look at some more functions. We're taking a short break. Let us consider the function f of x is equal to 3x plus 2. This function is a linear function. It's a linear function because the highest power of x is 1 in this case. Now, I want you all to know something. F of x is equal to y. All right? So on your graph, on your Cartesian plane, you can actually represent, instead of writing y here, you could write f of x because your f of x value corresponds to your y value. X is the same, it's your domain value, but your y value, you can write it as f of x. So I want you all to make a note of that, right? Y is f of x. Now, if you have f of x is equal to 3x plus 2, and I am looking at the values or the domain. So let's say the domain that I'm looking at is that x is greater than or equal to negative 2 and less than or equal to positive 2. There are two ways that it's three actually. I can represent this on the graph. I can represent it in a table of values, or I can represent it just as a set of ordered pairs, right? If the domain is x is greater than or equal to negative 2 and x is less than or equal to 2, it means that the set of values that x could take will be the set of, so I'm using my curly brackets, so it represents the set of negative 2, since x is greater than or equal to negative 2, negative 1, 0, 1, and 2. Those are my x values. So my domain is that, right? Now, my range will include all the values of y that I get when I have x being equal to negative 2 to x is equal to 2. Now, I can do this I could find my f of x values by using a table, which we've done before. So let me draw up a table. Right? So I can use a table where I write like this, and I put my x values and my y values. So it can be, gonna list my x values here. So my x values are negative 2, negative 1, 0, 1, and 2. Those are my x values. All right, and now my f of x values, well, when x is negative 2, f of negative 2, will be equal to 3 times negative 2 plus 2. So that would be 3 times negative 2 is negative 6, and negative 6 plus 2 is negative 4, right? When x is negative 1, my f of negative 1 value would be 3 times negative 1 plus 2. So that's negative 3 plus 2, which will be negative 1. When x is 0, f of 0 will be 3 times 0 plus 2, which is 2. When x is 1, that would be f of 1. So that's 3 times 1 plus 2, which will give me 5. And then when x is 2, it'll be 3 times 2, which is 6, plus 2, which is 8. All right, so those are my f of x values when x is going from -2 to 2. Right? Now, if I were to write these in a set of ordered pairs, right? If I were to write these in a set of ordered pairs, my ordered pairs will be -2, -4, right? It'll be -1, -1, 0, 2, 1, 5, and 2, 8. So my x values are these, and then my f of x values or my y values are the values that I worked out, right? So as you can see, I have represented it in terms of a table of values. I have represented it in a set of ordered pairs. I can represent it in a mapping diagram, right? So in my mapping diagram, I will have -2, -1, 0, 1, and 2. In my domain, this is my domain because these are my x values. And in my range, my f of x values, I will have -2 being mapped on to -4, -1 being mapped on to -1, 0 being mapped on to 2, 1 being mapped on to 5, and 2 being mapped on to 8. So the function here is that f of x is such that x maps on to 3 times x plus 2. That's what it means. Now, I can also represent this on a graph. So let's look at the graph. So it's 3x plus 2. Let's go on Desmos and sketch this graph for 3x plus 2. 3x plus 2. Now, granted, on my Desmos graph here, it's not, I don't have any restrictions on it. So this is the entire function where x is equal to, where the domain is -infinity to +infinity. All right, so let me show you. This is what the graph of the function f of x is equal to f of x is equal to 3x plus 2. This is the function of, sorry, that's too thick. Yeah. F of x is equal to 3x plus 2. And let me show you something. Just now we saw that some of our ordered pairs would be when x is -1, y was equal to 3 times -1. And look at this. Look on the graph here. When x is -1, right? Look, -1, -1. See? -1, -1. Trying to plot that point. I don't know how to do it. I can't remember how to do it. Anyway, we'll figure it out eventually. So yeah, so this point here is -1, -1. And as you saw, that's what we got, right? So I can therefore say, I can interpret this as f of -1 is equal to -1. Right? Similarly, when x was 0, that's this point, right? Because this point here is 0, 2, right? So I can represent this in function notation. This is f of 0 is equal to 2. So as you can see, you can represent a graph, a function on a graph as well. So let's zoom out a little bit. And somebody tell me, right, if you can, what would be f of 2 and what's f of -2? what's f of 2 and what's f of -2. Remember, you can work it out graphically, right? Because you could look at the graph and find out what f of 2 is, or you could just substitute the values algebraically, because we know that the function of f of x is defined as 3x plus 2. So what would be f of 2 and what is f of -2? Based on the graph here. What's f of 2 and what's f of -2? Is Nia there? Nia, are you there? No, Nia. Kaylin, are you there?
Yes, I'm here.
Okay. Can you tell me from the graph what f of 2 is?
F of 2,
Mm-hmm.
the 2 on the positive 2 on the x-axis.
Yeah. What's the value of f of 2?
What do you mean by that?
I mean, what is the corresponding? So f of 2, this means I want to know what is the value of the function when x is equal to 2.
I'm kind of lost here.
Okay. So just now I showed you all that you can find from on the graph, you can find any value. You could either work it out, right? You can work out what f of 2 is by substituting 2 into this function. You know how to do that, right? Like if I asked you to find f of 2, what would it be if I had to work it out algebraically?
3 brackets 2 plus 2,
Right, what would that be equal to?
8.
It'll be equal to 8, right? So to find f of 2, like if I did not have the function, if they didn't tell me that f of x was 3x plus 2, and they just gave me the graph instead, and I'm to find what f of 2 is, it means what point on that graph do you have the x value being equal to 2? So you have to find the point on the graph where x is equal to 2. Can you do that? The
Where
point on
x
the
is equal to
graph.
2.
Yes, where x is
Oh,
equal to 2.
right. So the positive 2 and then the line going straight up to hit the gradient.
No, honey. The graph is the red line, right? So
Yeah.
which point on that line is x equal to 2? Yes, that's how you locate where the x coordinate, where the x value on the x-axis is. So which corresponding y value corresponds, which value of y, sorry, corresponds with when x is 2 on the graph itself. Read off the point for me. The point on this graph where x is equal to 2. So yes, you're saying it correctly in terms of that's where you would find, this is what you're saying, right? This is where you'd find x of 2.
Mm-hmm.
So what is the point that it touches the graph where x is equal to 2? Because a point has two coordinates, right? A x value and a y value. What point is that?
So 2x and 8y.
Well, not 2x and 8y, but yes, 2,
So
8.
2 and 8.
Right. So this point here is 2. This point is 2, 8. Yes?
Mm-hmm.
So
Yeah.
therefore, f of 2 is equal to 8. Because look at here, right? When you do it algebraically, f of 2 is equal to 8. And if I were to write that as an ordered pair, it will be 2, 8. It really, this ordered pair, when you work out your function, right? When you have your function, this corresponds to a point on the actual graph of the function. So 2, 8 is a point on the function. If I had it in a mapping diagram, 2 will map on to 8. That's what it means. Or in other words, in function notation, f of 2 is equal to 8. So stay with me, Kaylin. What then will be f of -2? On the graph, can you find what f of -2 is equal to?
-4.
-4, excellent. So the ordered pair here will be -2,
-2,
-4.
-4.
Beautiful. So then f of negative 2, algebraically, if we were to just substitute it in the function, it would have been what? What would be the substitution algebraically?
F of -2 is equal to -4.
Yes, right? And if I were to just do it algebraically with the function 3x plus 2 to find f of 2, how would you do it?
Substitute the -2 into the x.
Perfect. So what would it be?
3 times -2 is -6, plus 2 is -4.
Perfect. Do you understand now? Does that make some
Yeah.
more sense?
Yeah, I
What
understand.
about, stay with me. Everybody's gonna do on this with me because I don't trust y'all when y'all tell me y'all understand. Kaylee, what about when f is when x is 4? Take your time because I kind of zoom out a little bit. So I want you to find for me what f of 4 is equal to. F of 4.
14.
That's right. That is right. F of 4 is 14 because f of 4 is from, this is where x is equal to 4. So as Kaylin was explaining first, you have to read from where x is equal to 4 on the x-axis, so that's over here, up to the graph, and then you read off the y value there, which would be 14. So Kaylee, what is the ordered pair? What's the coordinates there?
So 4 and 14.
Beautiful. And if I were to write it in, if I were to substitute it into the function 3x plus 2, what would it be? How would I write it out?
So f of 4 is equal to 14.
Mm-hmm.
And if you were to substitute, it would be 3 times 4 is 12, plus 2 is 14.
Excellent. Wonderful. I believe that you understand now. Right? Now, in the same way, right? Remember last week, right? We were looking at if I actually tell you that f of x is equal to 14, what is the x value? I want to know when f of x is equal to 14, right? So when f of x, which is your y coordinate, is equal to 14, what is your x coordinate? So when when f of x is 14, x is equal to 4. That's what it means, when they tell you that. So like if I tell you then, Kaylin, if I tell you that f of x, that's your y value, okay, guys? Your y value is your f of x values. So, Kaylin, if I tell you that f of x is equal to 5, what is your x value when f of x is equal to 5? Do you know what it will be?
1,
Yes, great. Tell me why.
because when you do the graph thing where
Hmm?
you draw the line from the 5 to the line, then straight down.
Yes, beautiful. Because I'm literally reading off what my f of x value is, which is 5. That's my y value. And when y is 5, x is 1. And algebraically, which is how we did it last week, we can actually work that out. Because if f of x is equal to 5, I am saying that 3x plus 2 is equal to 5. So then 3x is equal to 5, take away 2, which means that 3x is equal to 3, and so x is equal to 1. But as you saw, guys, you can read that off from the graph as well, right? If f of x is 5, that means y is equal to 5, and the corresponding x coordinates when y is equal to 5 will be 1. Okay, beautiful. All right, who is my next? Thank you so much, Kaylin. Thank you so very much. Isabel. Isabel, are you there? And girls, I will go through it with you as if I didn't even just go through it so many times. Each time I'm going through it with you again, I want to make sure all of you understand how to interpret a graph of a function. So Isabel, me and you now, honey. Ready?
Yeah.
All right. What about if I had the function f of x is 2x minus 1. So this is the function 2x minus 1, right? I would write this function in terms of, with function notation, this is the function, this is the graph of f of x is equal to 2x minus 1. So Isabel, if I wanted to know what f of 3 is, what is f of 3 from the graph? F of 3. It's 5. It is 5, right? Because as you can see, thank you. As you can see, buena donna Zeta. As you can see, when x is equal to 3, this is where x is equal to 3 here. So I'm going to read the points, read the coordinates of the points when x is equal to 3. So that's up to here, and then I read off the y value. So that is 3, 5. All right. Isabel, what about f of, sorry, what is the substitution if I were to work it out algebraically? F of 3.
So would it be 2x minus 1 is equal to 3? And
Well,
then
no. If you are given that f of x is 2x minus 1, and you
oh,
need to find f of 3, how would you work that out?
sorry, you just substitute 3 into x, so it'll be 2 by 3
Mm-hmm.
minus 1, so that's 6 minus 1, which is 5.
So you see how we did it from the graph, right? We found it from the graph, and then we also did it algebraically here, right? Tell me, what is f of 5 from the graph? F of 5.
9,
9. 9 is correct, right? And then algebraically, what would that be?
it'll be 2 by 5 minus 1, which is 10 minus 1, and that's 9.
That's right. So as you can see, girls, we can do it from the graph. F of 5 is from here to here, right? So that's where x is equal to 5. And then we read off the corresponding y value of that point, which is 5, 9. Two more, Isabel. What about f of 7? What is f of 7 from the graph?
18.
13 is correct because f of 7 is here. This is when x is equal to 7, and this is where it corresponds. That's the point. And that point, as Isabel correctly said, is 7, 13. Algebraically now, Isabel.
It'll be 2 by 7 minus 1, and that'll equal to 13.
Beautiful. Now, in the same way that you could find out the y value or your f of x value, f of x is y, in the same way how you could find out that value given an x value, you could do the opposite. I can ask you, what is the x value when f of x is equal to something else? So, for example, when f of x is 13, x is equal to 7. When f of x is 9, x is equal to 5. And when f of x is 5, x is equal to 3, right? So you can also get it like that. And we can work that out algebraically as well. So for instance, if I tell you that f of x is equal to 5, right? Algebraically, to find out what x is equal to, or the corresponding x coordinates when y is 5, I would say 2x minus 1 is equal to 5, and then I would work out what x is. So that would be 2x is equal to 6, and then x is equal to 3, which we got, right? So my question now, Isabel, is what is your x value, right? So find x when f of x is equal to 3. When f of x is equal to 3, what is x? When f of x is equal to 3, what is x?
2,
How much, honey?
2.
2 is correct, right? Because at this point here, f of x is equal to 3, and that corresponds with your x value of 2. So the ordered pair here would be 2, 3. So algebraically, that would have been 2x minus 1 is equal to 3. So then 2x will be equal to 3 plus 1, which is 4. And so x is 4 divided by 2, which is 2. What about when f of x is 1, Isabel? What is x? When f of x is 1.
Is it 1?
It's 1. Yep, that's correct. When f of x is 1, x is also 1. 1, 1. Do you understand it, love?
Yes, miss.
Beautiful. Okay, I'm trying to talk to Nia, but I don't know where Nia is. So let me see. Atina.
Hey, Miss, I'm here. Miss,
Okay,
I'm
hi.
here.
Oh, I called you just now. You didn't answer me.
Really? Oh, Miss, that was probably when I went in the kitchen to get something to eat. My
Okay,
bad.
honey.
Sorry.
Okay, that's okay, baby. Ready? Can you do one with me?
Sure, no problem, Miss.
All right, let's go. So let's say we had f of x is hold on now. X over 2 plus 1. See, yeah. All right, so your function is x over 2 plus 1, right? So my question to you, Nia, is, so this is a function, f of x is equal to x over 2 plus 1, or I could say a half x plus 1, right, Nia?
Yes,
What
Miss.
is, based on the graph, what would be f of 8? What is f of 8 from the graph?
That's wait. That would be 5.
That's right. It would be 5, right?
Okay.
Because 8 is here. So the corresponding y value is 5. So the ordered pair, Nia, what's the coordinates of that point? What's the coordinates of this point
Up
here?
point of this point here, it would be 5.5. Wait, no. Wait. My brain glitching. It would be 8 and 5.
8, 5, right? So f of 8 is equal to 5. So therefore, if I were to work it out algebraically, it would have been 8 over 2 plus 1, right? Which is 4 plus 1, which is 5. So you see how it's the same. You could work it out algebraically, or you could get it from the graph. Nia, what would be f of 2? What is f of 2?
F of 2 would be 2.
That's right. F of
Oh
2 is
yeah.
2 because it's here.
Okay.
This is 2 and this is 2. What's the coordinates of that point?
This would be 2 and 2 and wait. 2 and 2.
2, 2 in
Okay.
here. Correct. 2, 2. So, right, tell me what it would be algebraically. How would
What
I
you said,
write it?
Miss?
How would I write it in the substitution?
It would be 2 over 2 plus 1
Beautiful, which is 2,
equals 2.
right? What about f of negative 2? Nia, f of negative
Negative
2.
2. Wait, let me use my brain. 0?
Yes, because
Okay, my
that's
brain
this
was dead.
point. That's this point here at negative
Yes,
2,
Miss.
0. That's that point. Great. What about f of 0? What's f of 0?
1?
Yes, perfect. F of 0 is 1. Great. So the ordered pair there is 0, 1. Now, in the same way here, I can give you the f of x value and ask you what is the corresponding x value, right? Because your f of x value is your y value. So tell me, Nia, let me clear the graph for you so it doesn't be so confusing. Right. Tell me what is x equal to when f of x is 6? When f of x is 6, what is x equal to? When f of x is 6, based on the graph, what is x
So the,
equal to?
so the equation is equal to 6, and we need to find out what x
X
is.
is equal to, yes.
Okay,
Or
so
in
I'm
other
saying
words, what is your y value? Read off the graph, read off from the graph. When y is equal to 6, what is the corresponding x value? Because that's what it means. If they tell you that f of x is equal to a number and you have to find out what x is, it means that they're telling you the coordinates, the y coordinates of the point on the graph. So all you need to do is just like how you found the y coordinates when you had the x coordinates, now you need to find what the x coordinates is when you know the y value. So for instance, let me just give you an example, right? If I
let's have to
if I
look at
wanted,
though.
tell me, you tell me now.
We have to go about it, so we'd have to work backwards. So then 6 minus 1 is 5, and
No,
then
I don't want you to do it algebraically. I want you to do it from the graph for me.
from the graph. Okay, Mister,
Yeah.
you need to tell me.
So if I tell you f of x is your y value, okay? So you know how
Yeah.
before I told you what your x value was? So like I told you, Nia, what is the y value when x is -2? And you read off from the graph that it's 0. Or when I told you that the x value is 0, what's the y value? Or the first one when x was 4. So when x is 4, that's from this point here, the y value would be 3, right? Now I'm giving it to you in the opposite. I'm giving you the y value and I want to know what's the x value. So for instance, when y is equal to 4, this is where y is equal to 4, right? So on the graph, y is equal to 4, or f of x is equal to 4 at this point. So the corresponding x value there is 6. So therefore, like this point on the graph here, this point, the coordinates of this point is 5, 4, right? So I could say that f of 5 is equal to 4, right? Or f of x is equal to 4, so x is equal to 5. So now I'm giving you the f of x value, which is your y values, and I want you to tell me what the x value is. And you were correct in terms of your working backwards,
Oh,
right?
well,
But I don't want you to do it algebraically first. I want you to do it from the graph. So if when y is equal to 6, what is x equal to on the graph?
it would equal to 10.
That's right.
Right.
It'll be equal to 10. Correct. Yes, because this is where y is equal to 6, and this is your x coordinates. So f of x here is 6, and x is equal to 10 when f of x is equal to 6. Now I could have done it algebraically because I could say that f of x is equal to 6. So therefore, x over 2 plus 1 is equal to 6. So x over 2 is equal to 5, and so x is equal to 5 times 2, which is 10. See? So the coordinates of the point is, 10, 6. Nia, again from the graph, what is x when f of x is equal to 7?
What
What's
is
x when
this?
f of x is equal to 7?
That would be 11. Wait, no, 12.
12, that's right. It's 12, right? So
Yeah.
f of x is equal to 12, 7 here, and then the corresponding x value is 12. So the coordinates of the point or the ordered pair for there will be uh um It'll be 12, 7, right? And if you were to work it algebraically, you would say x over 2 plus 1 is equal to 7. So then x over 2 is 7, take away 1, which is 6. And so x is equal to 6 times 2, which is 12. Does that make sense, Leo?
Yes, it does, Miss.
Beautiful. Atina, are you back? I know just now you said you
Yeah.
okay, good. I want you to work these out with me now, okay? So I'm going to give you a new function and we're going to do exactly what I just did with Nia, okay? Um, right. So let's say we have the function 4x minus 3. 4x minus 3. Right. See any graph, honey? This is the
Yeah.
graph of the function. This is the graph of the function f of x is equal to 4x minus 3. Okay, honey, so tell me, Athena, from the graph, what is f of 2? F of 2, which means what is the value of the function or what is the corresponding y value when x is equal to 2?
Um, I'm not really sure at the moment. Is it like on the y-axis? Okay. Huh?
Where is x equal to 2? So you're looking for the point where x is equal to 2, right? So let me help
Mhm.
you. X is equal to 2 over here, right? Hold
Yeah.
on, let me write it in. Over here. This is x is equal to 2, right? So
Mm-hmm.
to find the point on the graph where x is equal to 2, I look up from it. So you see here? This is where x
Mm-hmm.
is equal to 2, and I read off the y value there. So the coordinates of that point, or the ordered pair, will be 2, 5, right? Because
Mm-hmm.
this point on the graph, x is equal to 2 and y is equal to 5. Now, if I were to substitute it algebraically, f of 2 would be equal to what? How would you do the substitution? How would you work this out algebraically?
So 4 in brackets, 2
Mhm.
minus 3,
Right. Work that out for me.
which that would be still 5. The answer would be 5.
Do you see why? Do you see how it's related?
Yeah.
It's related because any value of the value of x when x is equal to 2, y is equal to 5 on that graph, right? So like if I wanted to find f of 1, for instance, I could work it out algebraically, or I could look at the graph and see what is the y value when x is equal to 1. Can you find what the y value is when x is equal to 1 from on the graph? Atina, when x is equal
Um,
to 1, what would y be equal to?
when x is equal to 1,
Mhm.
um, 1.
Yeah, 1, because that's this point here, right? That's this point. So the ordered pair there is 1, 1. And work it out algebraically for me, Atina, f of 1. F of 1.
So is well, 4 in brackets 1 minus
Mhm.
3 should still
Yeah.
be just 1.
So it's 1. That's how we do it, right? So tell me now from the graph, what is f of which one we just said? F of 3, Atina. What's f of 3 from the graph? I'll zoom in a little bit for
I
you.
see it to the lines. Oh,
Okay, is this better?
yeah.
So let me just put in. So this is 3. Yeah, that line is 3. What is y equal to when x is 3? Let me zoom in a little more. I think this is the maximum zoom I could zoom in. Here we go. When x is 3, what is y? Can you see
9.
that, Chloe? What is it?
Yeah, I see. Yeah, it's 9.
It's 9. Yeah, it's this point here, correct? Algebraically, tell me what it would be algebraically. F of x is equal to,
So
I mean, f
4.
of 9 is f of 3, sorry.
So right. So 4 in brackets 3 minus 3, which would be 9.
Yeah, because it'll be 12 minus 3, which is 9. Right? So in the same way, Atina, how I could tell you, like, find the corresponding f of x value when I give you a value of x. So like what f of 3 was, I could give you the f of x value instead. F of x is your y value. So instead of giving you your x value, I'm going to give you your y value, and you are going to tell me what is the corresponding x value. Right? So for instance, for this one, I could have asked you, well, if f of x is 9, right? If f of x is 9, what is x? Well, you would look for 9 on your y-axis, because this is your y-axis is your f of x axis. So you'd look for 9, and then you would read what value of x it is, which is 3, right? So I'm going to give you your f of x value instead, and you're going to tell me what is the x value. Okay?
Okay.
All right. So if f of x is if f of x is negative 3, what is x? If f of x is negative 3, what is x?
1.
You sure? 1? Is this is the point, right? F of x is negative 3 over here. So what's your x value there?
Oh shoot.
So what's the coordinates of this point? This is something negative 3.
I'm not really.
It's 0. Because it's on the y-axis itself, right? So x is equal to 0 on the y-axis. This point here, Atina, f of
Mhm.
x is negative 3 here. This is on your y-axis. Do you see that? This is your y-axis that it is on.
Yeah.
This is your y-axis. So x, look, is equal to 0 on your y-axis. All right? Let's do another one. What about if f of x is, hold on. What about if f of x is negative 7? Negative 7. What is your x value when f of x is negative 7? By the way, these are your x values up here. Negative 4, negative 2, negative 3. These are your x values, right? It's just kind of lighter. So when
Unless you
f of
say
x
negative
negative
7.
7. Yeah, I said negative 7.
Um, well, I'm not really sure because the line is kind of cut off, but it looks closer to 0.
Well, let's draw our line and see. So if I draw my line from, this is negative 7 here, right? So up,
Yeah.
that would be negative 1. It's negative 1,
Yikes.
right? So don't worry. It's just hard to see because I drew it like that. But I'll give you some more where it's a little clearer. We could work it out algebraically, Atina. So if f of x is equal to -7, algebraically, what this would mean is I have to solve for x when 4x minus 3 is equal to -7. So algebraically, that would be 4x minus 3 is equal to -7, and then you solve for x. So it'll be 4x is equal to -7 plus 3, which would be -4. And so x will be -4 divided by 4, which is -1. So you could have worked it out algebraically as well, right? So let's do some more, but let me see if I could make this graph a little easier for you to see. All right, so we're going to go on the positive side. What about when, hold on, Atina, when f of x is equal to 25, what is x equal to? When f of x is 25, what is x equal to?
Y-axis, like you're going from the y-axis and add a calculate
That's
d.
right. Correct.
Okay.
Because your y-axis is your f of x axis. So we're looking from 25. So this is 25 here on your y-axis. So what is your x value when f of x is equal to 25? Can you see it from your end?
I can't really see the boxes very clearly, but I really not sure.
All right. So this is where f of x is equal to 25, right? At this point on the line. So now you need to read off your x coordinates of this point. Can you see it at the bottom or you can't see it?
Miss, is it 6 or 7?
It's
I don't
7. Yeah, it's 7, right? You could check it from here too. Like, let me show you. If you can't see it properly, like here, this is 1, 2, 3, 4, 5, 6, 7. So x is equal to 7 when f of x is 25. So the coordinates of the points will be 7, 25. So x is 7, f of x is 25. Any point, Atina, that's how you interpret it. Any point on this line would mean, so like this point over here, oops, sorry. Just now, right? So like this point here, right? The coordinates of this point, you could tell me what they are? That point that I highlighted here.
Is that 17?
Yeah, so and the x value is
It's 5.
5. So it was the coordinates of the point.
So 5 and 15.
17.
Oh, shoot, sorry.
Right? So 5 and 17. So 5 is your x and 17 is your f of x, right? Every coordinate, that's how it is. You know, coordinates are x and y, right? It is the same as x and f of x. So it means here, x is 5 and then f of 5 is 17. That's how you interpret it. All right. Let's do one more, Atina, and then I'm gonna move on to somebody else and stop torturing you. What about when f of x is, oops, when f of x is just now. Oh no, that's too, no, this is too narrow, too big. All right, Atina, what about when when f of x is You just did that one. When f of x is 9, what is x? When f of x is 9. I'm going to write in the numbers for you because I realize that you're kind of struggling to see them. This is 6, 7, 8, 9 on your y-axis or your f of x axis. And then on your x-axis, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. What is, Atina, when f of x is equal to 9, what is x?
3 as well as I could
Yeah,
try to tell.
yeah, that's right. It's 3. So what's the coordinates of the point?
So it's 3 and 9.
Beautiful. Good. Thank you. All right. Thank you so much, Atina. Let's see. Genesis. Genesis, did I do one with you like this as yet?
No, miss.
All right, so you think you understood when I was going through it with the others?
I think so.
Yeah, okay, let's do one, Lovey. Let's say I have the function 1/4 x plus 6. 1/4 x plus 6. Right, Jenny, can you make out all of these? You can make out the graph. You've seen it clearly.
Yes, miss.
All right. Tell me, what is f of 4? What is f of 4? F of 4.
7.
F of 4 is 7, correct. Right. So f of 4 is 7. And algebraically, Jenny, if I had to do that, right? Like if I had to find f of 7, given that given the function f of x is 1/4 x plus 6, what would be the substitution?
4 and 7.
Yes. Sorry, I wrote the wrong thing here. It was 4. Yeah. So sorry, the coordinates of the points will be 4 and 7. But how would I write it algebraically? Like if I know that f of x is equal to 1/4 x plus 6, how do you work that out?
1/4
Mm-hmm.
7 plus 6.
4. It'll be 4
Oh,
because x
4
is 4. Yeah. Yeah. And that would be equal to
7.
7. So the ordered pair here will be 4, 7. What about f of -4, Genesis? What is f of -4 from the graph? You can see that point where x is -4.
Yes.
What is it?
5.
It's 5. Perfect. Work it out algebraically for me.
1/4
Mm-hmm.
plus the 4 plus 6
You mean 1/4 of -4 plus
of
6.
4 plus 6.
Yeah, which is 5. Great. So the ordered pair there would be what?
-4 and 5.
That's right, -4, 5. Right. I wonder if I could, let me see something. -4, 5. Oh, there we go. Perfect. What about when uh find for me from the graph what is f of 7? What's f of 7? from the graph? Not f of 7, sorry, f of 8. What's f of 8 from the graph?
Seven? No, 6.
7. F of 8? Where is f of 8? Try again. Find the point. So f of 8 is here. This is 8. What's the corresponding point? I mean, the corresponding y value.
It'll be 8 as well.
It'll be 8 as well. No, you're correct. Look at there. See? 8, 8, right? So what about when find f of 16? F of 16.
Ten?
Yes, correct. 10. So that would be 16, 10. Great. So now I'm going to ask you, Jenny, to tell me what's the x value. Now I'm going to give you the f of x values instead, right? So the y values. Tell me what is the x value. So what is x equal to when f of x is equal to 9? What is x when f of x is equal to 9? When f of x is equal to 9, what is x?
Fifth. 16?
When f of x is equal to 9, x is equal to, let's see, note here. Look, when f of x is equal to 9, this is where 9 is, right? So
Mhm.
this is where f of x is equal to 9 on the graph. So what x value does that point correspond with?
12.
12. Beautiful. So what's the coordinates of the point?
9 and 12.
9, 12 is correct. And if we had to work it out algebraically, it would be, we would say a quarter x plus 6 is equal to 9. So then a quarter x is equal to 9 take away 6, which means that a quarter x is equal to 3. And so x is equal to 3 times a quarter. 3 divided by a quarter, which is 12, right? So that point there is 12, 9. That makes sense, Jen?
Yes, miss.
So whenever you have a point on the line, you could tell what is the x value and the f of x value. So like here, this x is 4 and f of x is 7. So we can therefore say that f of 4 is equal to 7, right? If I take this point over here, the coordinates of this point is 20, 11. So x is 20 and y or f of x is 11. So I can say that f of 20 is 11. All right. Thank you so much, Genesis. Safi, I'm just going to ask you to do this last one with me, and that would be it for class, okay?
Yeah.
All right. You were following along with the others?
Yeah.
All right. So let's do one. All right. So Safi, if I have let's see, 2x. Oh, let's just do, actually, I know, let's do x squared. Right, Safi? We're looking at this graph now. Zappy, what would
Yes.
be f of 2? What is f of 2? F of 2.
Oh, okay.
Based on the graph. What is the value of f of x when x is equal to 2? That's what I mean when I ask you what's f of 2. So you have to find the point where x is
Repeat.
equal to
I
2.
didn't. Miss, could you repeat what you just said? I didn't hear you properly.
So if I ask you what is f of 2, I'm asking you what is the value of the function? So what is the coordinate, the y coordinate when x is equal to 2? So you have to find the point where x is equal to 2 and tell me the y coordinate of that point. So f of 2, that's what it means. What is the corresponding value on the graph when x is equal to 2? Do you know how to locate the point x is equal to 2?
Not really, because I was paying attention and all the other ones were straight, and now I got confused because this one is curved.
Well, it doesn't make a difference because if I hide a piece of the graph like this, you can't really see that as a curve. It looks like a straight line, right?
Okay.
It doesn't really make a difference. It's the same principle. You have to find the point where x is equal to 2.
Okay. Mm.
Let me help you. This is your x-axis here,
Oh,
right? Your horizontal axis is where
5.
you read it from.
This
So
is just 5.
it is 5, correct?
Right.
Because
Okay.
x is 2 over here and y is 5. So the coordinates of that point is, what's the coordinates of the point?
2 and 5.
2, 5. Excellent. So f of 2 is equal to 5. And if I had to work it out algebraically, it would be f of 2 is equal to 2 squared plus 1, which is 2 squared is 4 and 4 plus 1 is 5. See how it works?
Yeah.
So your x value is your x value is your x value, and then your y coordinate is your f of x value. So 5 is f of 2, right? Tell me now,
Yeah.
Zappy, where is, let me put that point in since you did that. That was 2, 5, right? That's the coordinates of that point, 2, 5. Good. Zappy, what is f of 1? What is f of 1? F of 1.
Mm. 2.
Yes, f of 1 is equal to 2. The coordinates of the point will be what?
1, 2.
That's right. 1, 2. Beautiful, right? So f of 1 is equal to 2. So, Zappy, if I had to work it out algebraically, what would that be, honey? F of 1. How would I write that algebraically?
You would do 1 squared plus 1.
That's right, which is 2. Zappy, what is f of 0?
1,
That's right. What's the coordinates of the points?
0, and 1.
That's right. 0, 1. 0, 1. Great. All right. Now, Zafi, I'm going to tell you what the f of x value is now, and you're going to tell me what the x value is, right? So when f of x is equal to negative, so no, sorry. When f of x is equal to 2, what is x? When f of x is equal to 2, what is x?
One,
1 and,
one and two.
no, 1 here. So this is when f of x, so you actually have, this is a many to one function, right? So when f of x is 2, this is where f of x is equal to 2. You're going to see that it corresponds with two x values, positive 1 and, what about this side here? What point that would be? This
Mm.
point here.
Oh,
What's your x value?
my x value is -1
It's
and
negative
2.
1. That's right. So here you have, it is a function, but it is a many to one function because you have the same y value or the same f of x value, as you can see here, being mapped onto the same, different x values mapping onto the same y value. So you have -1 and you have 1 mapping onto the same value. So this is a many to one function. All right. Thank you so much, Safi. Okay, girls, that's it for today. Thank you so much. I know that it was a little long,